Alright, similar polygons. They have the same shape. But not necessarily the same size. Thank you. Alright, similar polygons. They have the same shape but not necessarily the same size. What's that mean? What that means is if a couple of polygons are similar, then maybe you got a small one and then you just got a bigger one. Okay? Or vice versa. You got a big one and you got a small one. But they're similar to each other. Okay? And in order for them to meet the criteria of similar polygons, there is a theorem there. Okay? So two polygons. Here's what you want to understand. Two polygons are similar if their corresponding angles are congruent. Two polygons are similar if their corresponding angles are congruent. And corresponding side lengths are proportional. So two polygons are similar if their corresponding angles are congruent and their side lengths are proportional. And here's what that means. In that picture there, you've got two quadrilaterals. You got the bigger one on the left that looks like this, and then a smaller one right next to it that looks like this. Something like this. The one on the left is ABCD. And the one on the right is WXYZ. And in that picture you're told that angle A is congruent to angle W, that angle B is congruent to X, that C is congruent to Y, and that D is congruent to Z. So now this definition, two polygons are similar if their corresponding angles are congruent. So in this case, corresponding angles are congruent. Alright, angle A and angle W correspond and they're congruent. Same with the rest of the angles and the shapes. Now the second part of the definition, corresponding side lengths are proportional. Well, here's what that means. You've got some side lengths on the left. You've got an 18, a 21, a 15, and a 12. And then in the shape on the right, you got a 6, 5, 7, 4. 6, and a 5, and a 7, and a 4. Okay? Now, proportional. Corresponding side lengths are proportional. Yesterday we said that a proportion is an equation showing two ratios equal to each other. So you can write these ratios a couple of different ways. All right? But here's what you're trying to find out now. Are the corresponding side lengths proportional? So if you start with something like this top side, okay? The ratio of this top side of the big shape to the top side of the small shape is 15 to 5. Agreed? This length is 15. This length is 5. If we write it as a ratio, it's 15 to 5. Is that equal to 12 to 4? Are those two ratios equal to each other? Well, what's 15 divided by 5? 3. And what's 12 divided by 4? It's 3 as well. So, isn't this proportional? These sides are proportional. All right? Now, another way to figure that out, if you can't simplify the fractions that easy, is you take 15 times 4, right? 15 times 4, which is 60, and 5 times 12, which is 60. And if the crisscross products are equal to each other, then the corresponding sides are proportional. All right? Now, the deal is all the corresponding sides have to be proportional. So if 15 divided by 5 equals 3, and 12 divided by 4 equals 3, what's 21 divided by 7 equal? Right, 21 over 7. Is that equal to 18 over 6? Okay? All of these ratios equal 3. 21 divided by 7 is 3. 18 divided by 6 is 3. So this is an example of two shapes or two polygons that are similar. All the corresponding angles are congruent, and the corresponding side lengths are proportional. Does that make sense? Both of those scenarios have to be true in order for the shapes to be called similar. All right? Make any sense? I hope. Look at example 1 down there on the bottom. It says that if triangle FGH is similar to triangle JKL, list all the pairs of congruent angles and write a proportion that relates to corresponding sides. Okay, so here's what you're going to be doing in a problem like that. If triangle FGH is similar to triangle JKL, list all the pairs of congruent angles. All right, so look, based on this description, they draw the two triangles for you. But once you've got this written description, I don't think you need the picture. All right, here's your two triangles. You got FGH, and you got LKJ. List all pairs of congruent angles. So our congruent angles. What angle is congruent to F? J, good. Because they're both first in the description, right? And G, what's G congruent to? Good. And H is congruent to L. So there's your list of all the congruent angles. And write a proportion that relates the corresponding sides. A proportion that relates the corresponding sides. All right, so follow me now. Here's your proportion that relates the sides. We're going to take side FG and we're going to put it over. Which side do we put FG over? We use the first two letters, so we got to put it over JK. All right? And that has to be equal to. Now, let's pick since we use the first and second letter in the first ratio, let's use the second and third letter in the second ratio. So GH goes over, what's our denominator for GH? KL, good. Okay, so look at what we've done. We've used the first and second letter. We've used the second and third letter. So the numerator in our last ratio is going to be the first and last letter. So FH goes over. What does FH go over? If we use the first and last there, we use the first and last here. So JL. Alright, so the question was, if the triangles are similar, this one squiggly line means similar. Alright? If the triangles are similar, list all the pairs of congruent angles. We did that. It's right here. And write a proportion that relates to the corresponding sides. Here's our proportion that relates to the corresponding sides. That's right there. Does that make sense? All right, good, good. Take a look at the next page, 470. The ratio of the lengths of the corresponding sides. Two similar polygons. Is called the scale factor. All right, the ratio of the lengths of the sides is called the scale factor. Alright? The ratio of the lengths of sides of two similar polygons is called the scale factor. So look, back here on that first example we did, right here, the ratio of the corresponding lengths of the sides. Remember, we wrote the fraction 15 over 5. All right? 15 over 5 would be what's called a scale factor. All right? 15 over 5 simplifies to 3 to 1, doesn't it? The scale factor of polygon ABCD to triangle WXYZ is 3 to 1. Because all of the corresponding sides were in the ratio of 3 to 1. The big shape was 3 times bigger than the little shape. Okay? So the ratio of the corresponding sides is called the scale factor. So on page 470, they give you a diagram there. It says that triangle ABC is similar to triangle XYZ. Alright? The scale factor of ABC to XYZ. So scale factor. Of ABC to XYZ. If they ask for the scale factor of ABC to XYZ, whatever is listed first goes in your numerator. And whatever's listed second is the denominator. Alright? Scale factor of ABC to XYZ. In this case, you got side AB that's 6. Alright, side AB is 6, and side XY is equal to 3. So the scale factor of ABC to XYZ is 6 to 3, or 2 to 1. 2 to 1. Okay? Scale factor of ABC to XYZ is 2 to 1. They also ask you for the scale factor. Understand this difference. Scale factor of XYZ to ABC. Alright, when they change the order of the vertices of the triangle, now the side from XYZ needs to go in the numerator. The XY side that was 3, it goes in the numerator. And the AB side from the second triangle goes in the denominator. Okay, so the scale factor of XYZ to ABC is 3 to 6. 3 to 6 is the same as 1/2, or 1 to 2. When they ask for the scale factor, whatever's listed first goes in your numerator. Whatever's listed second goes in the denominator. Okay? The order matters there. The order is real important. Making any sense? Alright. Let's take a look at example 3 on page 471. It says in the diagram, ACDF is similar to VWYZ. Alright? And you've got this shape up top that kind of looks like this. And then you got a shape below it that's a little bit smaller and flipped over, and YZVW. So we got a 12, and we got an X, and a 9, and a 10, and a 6, and a 3y minus 1. Okay, now you're going to be taking what you did yesterday, which was solving those proportions, and you're just taking it one step further. You're given a similarity statement. You're told the two shapes are similar. Within the similarity statement, you can write a proportion. You're asked to solve for the variables, or you're asked to find x and you're asked to find y. So let's start off with writing a proportion. This side FD, which is the third and fourth letter in this description, that's your x. And if you put it over the third and fourth letter in the description on the right, that is your y to z, which is 10. And now, you're going to make that equal to let's take this side CD. Side CD, which is the second and third letter, and that's 9. And it's going to go over the second and third letter of the description on the right, which is your WY, which is the 6. So what we just did right there is we took a similarity statement and we wrote a proportion. Now, yesterday you solved these proportions, and you're going to do the same thing today. So you take your 6 times x, which is 6x, and you make it equal to 10 times 9, which is 90. And if you divide both sides by 6, then x is equal to 15. Make sense? Alright, now you would have to do the same thing for this 3y minus 1. So if we take this 3y minus 1, alright, and in this case, the 3y minus 1 is represented by, or is side VZ, V to Z. It's got to go over side AF. Alright, and side AF is 12. And we're going to make that equal to. Now let's use this side on the left, this 6. And that is side WY. Middle two letters again. Alright, WY is 6. And we're going to put that over. We're going to use the middle two letters again, which is CD, which is the 9. Alright, so now again we took a similarity statement, we wrote a proportion, and we're going to solve for y. So we're going to crisscross multiply. Our 9 times 3y minus 1 equals 12 times 6, which is 72. Distributive property on the left. 9 times 3y is 27y, minus 9 times 1 is 9, equals 72. Going to add 9 to each side. So 27y equals 81, and then I'm going to divide by 27. So y is equal to 3. Alright, your x is equal to 15, and your y is equal to 3. Any questions on those first 3 examples? Okay. Your assignment for today is on page